This video covers topic 16.1 over exponential functions. This is day 1 of this new unit. So we have examples of exponential functions here on the left side, and if you notice, each of these examples, the x is in the exponent. So that's how we can determine that these are going to be exponential functions. Over on the right side, we have examples that are not exponential functions. If you have just a plain x where it is, that is a linear function. And if you have an x squared, that's what we just studied in 15, which is quadratic functions. So those look like a U, and the x's look like a line because they're linear. So we're going to see what exponential functions look like today. So an exponential function is where it is written in the form y equals a times b to the x. Now a, we have a change here. A is our new y-intercept. So when y equals mx plus b, b is our y-intercept, but here a is our y-intercept. A is also our initial value, so it's where we start, our starting value. So now b is the rate or the base, and x is still the input. So on your notes, if you label a times b to the x, it becomes very clear. Our a is 2. Remember, our a is our new y-intercept, so our y-intercept is 0, 2. And then our b value is 3. Your b value is always the one that has the tiny x on the top next to it. Now, to determine if this is increasing or decreasing, I'm going to put it into y equals. So I have 2 times 3 raised to the x. Now my little x is there, but I use the up arrow to get up into the exponent. So when I click graph, this is what my graph looks like. So we're going to do just a real quick rough sketch. And this one is increasing. I know that it's increasing because we read graphs from left to right. So as I follow the graph on the left, it goes up and is therefore increasing. So for the second one, we write a times b to the x. Our a value is 13, so our y-intercept is 0, 13. Our b value is 0.2. And y equals, I'm going to plug this in, so 13, parentheses, 0.2, close parentheses, up arrow, and then x. And on my graph, this looks like that. So this one, as we read from left to right, is decreasing. For the third one, we have y equals a times b to the x. Now, if you have one like this that looks kind of weird, start with your b value. Your b value is always what you have the exponent of. So b is 1/3. Now, there's no numbers left. So what does that mean? Well, a can't be 0 because we know anything times 0 is 0, and if it was 0, it wouldn't be written. So the only number that we know if it's not written that actually has a value that's not 0 is a 1. So a is an invisible 1 right there. So therefore, my y-intercept is 0, 1. When I plug this into y equals, I have my fraction of 1/3 raised to the x. When I click graph, my graph is decreasing because it is going down. So if we do the same thing over here, my b value is the easiest to start with because b is always directly attached with x. So b is 4. There's nothing else in front, so that means a has to be 1 because remember it can't be 0. So when I plug 4 raised to the x into my calculator and take a look, this one is going up, so it is increasing. Now on page 2, they talk to us about an asymptote. An asymptote is where your line or your function gets very close to a value but does not touch. So right here, where we have this dotted line, it's hard to see because the way the graph looks, it looks like this line is crossing over the asymptote, but it actually gets really, really, really close to 0, but will never have a value for 0. So if we fill in what we know, our a value is 3 because it's the number in front. Remember, our a value is also our initial or starting value, so down there all of these numbers need a 3. My b value is what's attached with x, so b is a 2. As we can see, this one is going up, so it is increasing. My domain is going to be all real numbers, which is the same as the double R. Now my range and my asymptote are going to be related. My asymptote has been labeled for me, or I just labeled it, is y equals 0. It's where your line gets really close to 0 but does not actually cross. So for my range, I'm starting down at my y's. We know that it gets really close to 0 but does not touch, and then goes up from there, so my y's are getting greater than 0. My asymptote will always be a horizontal line because this one's going across. Also because my asymptote has the letter y in the equation, that makes it a HOI. So for the second one, my a value is an invisible 1, so my y-intercept is 1, and my initial value is 1. My b value is 1/2 because that is what is directly attached with x. And this one, as we go from left to right, is decreasing. Domain is always all real numbers. Now, we've seen on some test questions that the state might put onto your EOC at the end of the year. They've also shown your domain for all real numbers looking like this with a negative infinity to positive infinity, so I'm putting that on there as well. Now, my y's go down to 0, but they go up from there. They don't go down from 0. They go all the way down to 0, but it's everything above 0. So y is going to be greater than 0. All of the ones that we are looking at today, at least, are greater than. My asymptote is whatever my range is because it gets really close to 0 but does not cross. And, of course, we talked our asymptotes are always going to be horizontal. So, in the exponential function, y equals a times b to the x. If b is greater than 1, like example 1 on this left side over here, my graph is increasing. So if the number with x is bigger than 1, so 2, 3, 4, 1.1, any of that will be increasing. And then if it's between 0 and 1, like a fraction or a decimal, it will be decreasing. So it will go down from left to right. On the back, we're asked to identify domain, range, and asymptote. So my domain is going to be all reals. My range, this is getting really close to 0, so y is greater than 0. Therefore, my asymptote is y equals 0. As we move from left to right, this is decreasing. So a possible b value would be anything between 0 and 1. So we don't have any negatives, but 1/2, 1/3, anything with a fraction or a decimal. And then my initial value, my starting or my y-intercept, is at 1. So, as we said, domain is always all reals. On problem 2, my y's are getting really close to -4. And my asymptote will be at -4. As we read from left to right, this is decreasing. A possible b value, because it's decreasing, would be something like 1/7, anything that is a fraction or a decimal. And my y-intercept is 0,4, because that's where it crosses the y-axis. Problem 3, my domain is all reals. My range is getting really close to 2, so my asymptote is at 2. As we move from left to right, this one is increasing. So a possible b value could be 2, 7, 27, 5,000, anything bigger than 1. And my y-intercept, it crosses at 0,3. To finish this off, they are asking if these functions are linear, quadratic, or exponential. So linear is going to look like a line, and it's just going to have a plain x. Quadratic is going to look like a u and have an x squared, and exponential has an x in the exponent, so b to the x. So something with an exponential would be 10 and 11. 11 looks like an exponential graph, and 10, the function, is exponential. Linear, just a plain x, so something like 8, and it looks like a line, like 12. And then quadratic looks like a u and has an x squared. So 13 looks like a u, 9 has an x squared.